everyone, welcome back to the session. So in the previous session we have seen about the different architectures and we have seen the what is the archetype, we have defined the archetype, and let's go for the next topic is assessing alternative architecture designs. So what is the architecture designs? We have the different types of architecture designs. In previous session we have seen what are those. So we have seen about the object oriented architecture, call and return architecture, data flow architecture, okay, layered architecture. So like that we have seen the four types of architectures. Then so apart from those architectures, we have also seen further some of the different architecture, alternative of the architecture design. For some softwares, those architectures may not be suitable. So at that time, at that particular condition, at that particular situation, we can go for the some alternate architecture designs. So what are those alternate architecture designs? Let us say in this session. Okay. So an architecture trade-off analysis method. The first point is the architecture trade-off analysis method. So what is that? So alternative for the architecture design is the architecture trade-off analysis model. So what is that? So the Software Engineering Institute, so SEI is one of the institute. So it gives some guidelines. Okay. So one institute will be there for the software engineering. So this institute has developed some architecture trade-off analysis method. So that in shortcut we call as a ATAM. Architecture trade-off analysis method. ATAM. So architecture trade-off analysis method. Okay. So what is that? So that it establishes an iterative evaluation process for the software architectures. So what are the software architectures we have seen in the previous session? So in order to get some more architectures design methods apart from those, so this SCI has established one ATAM, so architecture trade-off analysis method. So what is it? So the design analysis has that are followed some performed iteratively. So whatever the actions we have to perform in the architecture, so we have to do some iterative process. That means in the incremental model. So what are those? The first point is collect the scenarios. So in requirement analysis, we will follow some of the methods. Okay. So scenario based method, class based methods, and flow oriented models and behavioral models. In those four models, in those four analysis, what we do? So we have to collect some scenarios. Okay. So a set of use cases is developed represent the system for the user's point of view. That means in use case diagram, what are the use cases you give? You have to refer, say according to the actor's point of view. That means user's point of view. You have to collect all those scenarios. Okay. So that is the first point. Second point, elicit requirements. So what are the requirements we have to consider? Whatever the requirements we have not considered, so we have to elicit the requirements, and also we have to elicit the constraints. What are the constraints we have to consider? So if I require, so whatever the requirements I want to implement in this software project, so what are the constraints I will get? And also what is the environment discussion? So in what environment we have to develop? That means in what software or in what. So in what environment is nothing but in what way it has to be developed. So in what type of software I have to use, what type of tool I have to use. So we have to consider all those things. That is the second point. And coming to the third point, so describe the architecture styles and patterns. So we have seen the patterns in the previous session. So okay, patterns are nothing but whatever the implementations we have to do in middle of the development, in middle of the software engineering. Okay, so that is a patterns. We have to follow some patterns are nothing but there are some mechanisms. Okay, whatever the patterns that have been chosen to address the scenarios and the requirements. So what type of pattern you have to follow in order to address some scenarios? For example, if you want to implement some more changes in the middle of the system development, then what type of pattern you are utilizing? So what type of scenario you are considering in that? So what type of requirements you are implementing in that? We have to take that. And next, the fourth point is process view for analysis of the system performance. So how the system will perform. So if you have given some input, what type of output we are getting. So how the system is getting the performance. We have to know the view. That is a process view. And fifth one is a data flow view. So how the information is transferring from one component to the other component. So to which the architecture meets the functional requirements. Okay. So that is the fifth point. And next, sixth point, evaluate quality attributes. So by considering each attribute is in isolation. So attributes are nothing but the values what you are giving. Okay. So if you are giving the some input, so what is the output? So is it getting the accurate or not? So you have to evaluate at each and every step. And next, seventh point is identify the sensitivity of quality attributes to various architectural attributes for a specific architecture style. So we have the different types of architecture styles. Okay, in those architecture styles, what attribute you are considering? So how it is effectively working? Okay, we have to consider all the sensitive part of the quality attributes. And next, eighth one is critic candidate architectures using the sensitivity analysis conducted in the step 5. So critic and candidate architectures means in whatever the step 3. So whatever the styles and patterns you are following, okay. So that developed in the step 3, we have to see the what are the architectures that you are used, and also using that we have to some analysis as to conduct. So that is in the 5th step. So in the data flow, we are analyzing the degree to which architecture meets the functional requirements. So whatever the architecture you are drawing, we are taking for the software. So that architecture is meeting the requirements, functional requirements or not. So we have to check. These are the 8 points. So for the as alternate for the architecture methods. Apart from those 4 architecture models, we can also assess the architecture models by using these 8 steps. And next topic is architecture complexity. So we said that architecture is a blueprint. So it gives how the components will interact with each other, how the information will exchange between the components that will be seen in the architecture. So what is the complexity in the architecture? What are the conditions in that? So what is the complexity if you follow the architecture if you not follow the architecture? So what is the complexity? So a useful technique for assessing the overall complexity of the proposal architecture is to consider dependencies between the components within the architecture. So what are the dependencies in the architecture? That means there will be some attributes, there will be some components which is dependent on one another component. For example, in the safe home security, so the control panel will depend on the sensor. If the sensor gives some sensitive, whatever the things have to, it has to be controlled by the control panel. Okay, so like that, what are the components are dependent with each other. So the complexities depend upon the between the components, whatever the components within the architecture. So these dependencies are driven by information control flow within the system. So Jaho suggests 3 types of dependencies. So what are the 3 types of dependencies? Basing upon these type of dependencies, we can say there is a complexity in the architecture. So what is those dependencies? The first one, sharing dependencies. So represent dependencies relationship between the consumers who use the same resource or producers who produce for the same consumers. So sharing dependencies are nothing but it uses some dependency relationship between the users and also the resources. For example, so you are taking some print. Okay, print is a one resource. In operating system, the resource is some printing is a one resource. Okay, so you are printing something for some user. At the same time, another user came and asked the same another print from you. That means whatever the print you are giving to the some user, you have to share the same print to the another user. So that is a dependency. So that is the sharing the dependencies. We call it as the sharing dependencies. And next, second one is the flow dependencies. So what is the flow dependencies? This relationship between producers and consumers of the resources. Producers means who are producing, that means the developer, okay, and the consumer. So that is the producers and consumers of resources. So flow dependency gives the relationship between the consumers and producers, whereas the sharing dependencies will give the consumers who use the same resource or producers who produce for the same consumers. And next, third one is Constraint dependencies. So constraint dependencies, constraint, that means a condition. So what are the constraints on the relative flow of the some set of activities? So there will be some softwares. So okay, there will be some relationship between the some dependencies because we can say flow of control among some set of activities ATM. Okay, let us take the ATM. So in ATM, if you are inserting the ATM card, then only it will ask the PIN number. So there is a dependency. Okay, that is the constraint dependencies. So if you enter the wrong PIN number, then it will ask again the it will give you some more chance, one more chance, or else it will reset your transaction. So there is a dependency between the card and the ATM machine. Okay, there is a dependence, constraint dependencies. And next one is architectural mapping using data flow. So using the data flow, how the architectural mapping can be done. So a mapping technique called structured design. So this mapping technique we call as a structured design is often characterized as a data flow oriented design because it provides a convenient transition from a data flow diagram to software architecture. So in order to draw the architecture, first you have to go for the data flow diagram. So why we are using the data flow diagram? So in data flow diagram, each and every step it will give the information. So from what point of data is going to the what to what. Okay. So for example, ATM. Let us take the ATM. In ATM, after inserting the ATM card, it will take the some PIN number. So after taking that simple PIN number, so that PIN number will goes to the bank database. So in bank database, it will check whether the PIN number what you have given is correct or not. If it is correct, then it will ask some transactions. Okay. So the transition information flow. So whatever the data flow diagrams you are representing, the program structure is accomplished as a part of a 6-step process. So whatever the data flow diagram we are drawing, okay. So in order to get the program structure, so whatever the data flow, that means whatever the data flow diagram you are drawing, so what the diagram you have drawn, in order to put it in some programming structure, so we have to follow some 6 steps. Okay. So what are those 6 steps? The first one is the type of information flow is established. So what type of information is flowing? We have to know. Next, flow boundaries are indicated. So what are the boundaries? So if you have given it will ask some ATM machines will ask press 0 to 55 or it will ask us type some numbers. Why it is asking? So we have to know some boundaries. Okay. So the DFD is mapped into the program structure. And next, control hierarchy is defined. So how the controlling is going on. Okay, at each step. So if it is a false, so how the control is moved to another for asking some more chance. So if it is true, whatever the password you will get, so then what is the control flow? Okay. Next, the resultant structure is refined using design measures and heuristics. Whatever the structure, whatever the architecture you have drawn, so that is refined using the design measures. So whether it is following some design principles or not, whether it is designed according to the some design concepts or not, we have to take some measures. Okay, so by using those measures, whether it is the data flow program is structured or not, we have to see. The architectural description is refined and elaborated. So whatever the architecture, whatever the architecture description we have given, so we have to elaborate. Elaborate means we have to write in a clear description in the one notes. We have to maintain one documentation, project documentation. And next, and next one is the resultant structure is refined using the data measures and heuristics we have seen. So the architectural description is refined and elaborated. And next, in order to perform the mapping, so these are the 6 steps we have to map. So whatever the data flow diagram you have drawn, in order to keep it in the programming way, so we have to follow these 6 steps. After following these 6 steps, in order to perform the mapping, So the flow must be determined. So what type of information is flowing? So one type of information is called as a transform flow. So we are seeing the type of information. So what type of information is? One type of information we call as a transform flow. Another type is a data flow. Okay. One type of information flow is called as a transform flow, and it exhibits a linear equality. And data flows into the system along an income flow path where it is transformed from an external world to representation into the internalized form. That means we are using some arrows. So one is the inflow. So inflow is nothing but incoming flow. One is the outflow, outgoing flow. So that is a transformation of the transformation of the data from one point to another point. Finally, it flows out of the system along an outgoing flow path that transforms the data into external world. So it is about these two arrows. So if you have it is an input inward, that means internal arrow means then it is taking some internal values within the system. Okay. If it is the outline, that means out arrow. So we call it as the outgoing flow. So that is transforming the data into the external world. That means out screen. Maybe for example, if it is a laptop, it will display on the screen. That is the external world. Okay. And next coming to the transform mapping. So how to transform the mapping? So transform mapping is a set of design steps. So it allows the DFT with the transform flow characteristics to be mapped into a specific architecture style. So in the previous model we have seen what are the mapping. So how the architectural mapping using the data flow. So by using the data flow diagrams, how we can represent in the architectural manner. And this here we are seeing how the data flow diagram with flow character to be modified into some architectural styles. Okay. So to map data flow diagrams to a software architecture, you would initiate the following design steps. In order to follow the step, first one is step 1. Step 1 is review the fundamental system model. So what is the system model? So what type of model it is? Step 2, review and refine data flow diagrams for the software. So what are the data flow diagrams we are drawing? So what is that? What is there in that? We have to check once. Step 3, determine whether the DFT has transformed a transaction flow characteristics. So what is the inflows, what are there? Outgoing flows, what are there? So what it is getting, what is how it is transforming from one transaction to another transaction, one data to another data, how it is transforming. So we have to check, we have to determine. Step 4, isolate the transform center by specifying incoming and outgoing flow boundaries. So what is the incoming boundary, outgoing boundary, we have to check. So step 5, perform first level factoring. So first level factoring is one of the technique. Okay. So that means level 0, level 1, how we have in DFT like that. And next step 6, perform second level factoring. That means DFT level 2. And next step 7, refine the first iteration architecture using the heuristic for improved software quality. So after refining after performing the second level factoring, then we have to develop some architecture style by using the heuristics in order to get some quality of the software. So this is a transform mapping. And next one is a component level design. So what is a component level design? So component level design occurs if the first iteration of the architecture design has been completed. So after completion of the architecture design, then we go for the component level. We have seen the one diagram in the starting of the unit that is in a triangular shape. So first we have the data flow, and secondly we have some architecture design, and thirdly we have the interface design, and fourthly we have the component level. Component level design. So now we are in this step. So component level design. So data flow is in the requirement analysis. In requirement analysis, we have seen the what is the data flow. Architectures, we have seen the what are the different types of the architecture. So interface is nothing but some designing concepts. So whatever the we are transforming. So what is the program structure we are transforming, that is the interface. Next one is the component level. So we are seeing the component level. So component level design occurs after the first iteration of the architecture design that has been completed. Okay, at this stage the overall data and program structure of the software has been established. So at this stage we have to take all over the data, whatever the data we have and whatever the programming structure of the software. So we have to develop, we have to look into that. The intent is to translate the design model into operational software. So in component level, whatever the design you did, whatever the architecture you drawn, whatever the program, whatever the thing you have designed, so that it has transformed into some programming model, into operational software. That means you are writing some code, that is a component level. Okay. So what is a component? So we have said there is some components, we have said that what is a component. So let's think what is a component, what is the definition of the component. So a component is a modular building block for a computer software. So how, in order to build some house, how the bricks are arranged, how the cement bricks or normal bricks are arranged in order to build the building. Like that, in architecture model, in software development also, so component also is nothing but component is also a component is also a modular building block for computer software. So what is a component? So component is a modular building block. We call as a modular. Modular is nothing but a unit, small part. Small part is called as a modular building block for computer software. So unified modeling language specification define a component as a modular, deployable and replaceable part of a system. So we have seen the unified modeling language. What is a unified modeling language? The diagrammatic representation of software is a unified modeling language. In that we have some diagrams, behavioral diagrams, flow-oriented diagrams, that means sequence diagram, class diagram, object diagram, use case diagrams, by using those. Okay. So this unified modeling language will define the component as a module. For example, let us consider the ATM. Okay. ATM, actor is a one component. ATM is a one component. Bank is another component. Okay, so these are the three components. Different modules. Actor is one module, ATM is a one module, bank is a one module. Okay, so where this modular, deployable, replaceable as a part of a system, then encapsulate means encapsulate is nothing but like wrapping. So how the chocolate is wrapped in a chocolate paper, like that. Encapsulation, implementation, exposing a set of interfaces. So interfaces are nothing but what are the actions we are doing between these two. Okay. So the true meaning of a term component will differ depending upon the point of view of the software engineer who uses it. So we can't say the component definition is a constant one. It will be differ. Depends upon the software. Depend upon the some developers who uses the software, who develops the software. That is a component. So next one is a object-oriented view. So we have seen the component level. So now we are going for the object-oriented view. In the context of the object-oriented software engineering, a component consists of a set of collaborating classes. In object-oriented, so we call component as a nothing but it is a set of collaboration of the classes. Collaboration of classes means number of classes are interacting with each other. Like this. For example, class is some rectangular having the class name CM. Class name having some attributes, having some operations. So this we can say this is a class 1. This one is collaborating with the another class. This is a class 2. This is also collaborating with another class. Because we can say as class name 3, having some attributes and operations. So this collaboration of the classes set is called as a component in object oriented. What is the definition we have seen in the previous? Component is nothing but some modular. Yes or no? So component is a modular building block for computer software. But we also said that this component definition will be differ according to the users. So in object oriented view, the component is defined as a set of collaboration of the classes. So each class within a component has been fully elaborated to include all attributes and operations that are relevant to its implementation. So I said the class is composed of some attributes and operations. Is fully elaborated to include all attributes and operations. What are these attributes and operations? Relevant to its implementation. In order to implement that class, what are the attributes required for that? What are the operations are required for that? Okay. As part of the design elaboration, all interfaces that enable the classes to communicate and collaborate with other design classes must also be defined. So to accomplish this, you begin with the and elaborate the analysis classes and infrastructure classes. Okay. So this is in order to communicate these attributes and functions, operations. So we have to communicate. How we have to design the classes. We have to know. And next one is a traditional view. So what is a traditional view? So, in the context of the traditional software engineering, a component is a functional element of a program. So, in traditional view, the component is defined as the element of a program that incorporates processing the logic, internal data structures that are required to implement the processing logics. So, in object-oriented view, component is nothing but it is some set of collaborating classes. Whereas in the traditional view, is defined as some functional element, which has its logic, which is going to some process logic, and also which has carrying some internal data structures, so which is going to implement the processing of the logic, and also enables the component to be invoked and data to be passed to it. So in traditional view, the component will act as like a functional element. Okay. So in traditional view, this component is called as a module. So we said that modular building block. So module means some unit. So resides within the software architecture and serves one of the 3 important roles. What are those? A control component that coordinates invocation of all other problem domain components. And secondly, a problem domain component that implements a complete partial function required by the customer. And third point is infrastructure that is responsible for the functions. So it adds in the 3 views. One is coordinates and control, and second is if it is any problem domain, then components some complete or partial function which is required as per the customer. And third one is it acts as a responsible for the functions that support the processing for the required in the problem domain. So this is a traditional view. So by this, so the summary of the session is so we have seen some assessing the alternative architectural design, and we have seen some of the architectural design components. and we have seen the component level design. In component level design, we have seen the definition of the component in two ways. One is the object oriented and next one is the traditional view.